Hey everyone, I'm Zach Wallace, and this is our team's Capstone project, the OSU Experiential Learning Hub, or ExpHub. Our team includes Demetrius, Joel Vandiver, Neil Juan, and myself. Our team responsibilities were divided across the full stack. Demetrius focused on the database, Joel worked on the student front end, infrastructure, and deployment. Neil developed the hub backend, API, and data model, while I focused on the admin front end. Our project partner was Dr. Rachel Jones. So, why build an experiential hub? OSU offers many experiential learning opportunities, but they are fragmented across departments and websites, making them difficult for students to find and difficult for staff to manage. The XP Hub is meant to address both problems by centralizing opportunity discovery for students and providing administrators with a more unified system for managing postings. This term, our team focused on the project's foundational architecture phase. Our primary goals were to deliver a full stack prototype, student search functionality, admin CRUD functionality, and accessibility alignment. Future Capstone teams can build on that foundation by adding OSU login integration, AI chatbot features, analytics dashboards, reporting tools, and workflow automation, with the eventual pilot launch this fall. At a high level, the system supports both a student experience and an admin experience. The front end connects to the hub backend, which communicates with the database, while infrastructure supports development and deployment.
Hi, my name is Joel Vandiver, and these are my contributions to the OSU Experiential Learning Hub. I started by building a style guide from the OSU Madrone theme so that our styles would align to the rest of the OSU ecosystem. I also built a landing page to introduce the Experiential Learning Hub to students and faculty. I just provided extra content and explanations for what the hub is and how it helps students find different learning opportunities throughout the OSU system. My primary app that I built was the search view to find the experiences based on the learning filters or the filters from campus or colleges or departments. I also spent time building the infrastructure automation so that we could deploy it to our local development systems and also to Azure. I created the private GitHub organization and repositories because we'll be handing this off across terms to different teams. I set up dev containers so that our dev tooling would be identical across uh, all developer systems using Docker and VS Code extensions. I primarily used React and TypeScript and the Bootstrap from OSU Madrone theme. I Reactified the theme and used TypeScript for type safety and React.js because of its broad industry support. And also we had used it in other classes at OSU. I used Bash and Linux for cloud native support to build the infrastructure. I used Docker to build a local dev stack of services and Docker Compose. I also built the front end into the back end. The back end's a Python fast API app, and I built the app into the Docker image containing the back end. As far as some of the reflections I have, I originally planned to focus solely on the front end for the search view and landing pages, but I very quickly realized that we needed to build some infrastructure to deploy the stack to our local systems and also to build it and deploy it to Azure. The primary challenge we had was I had planned to just build that local dev stack, but we learned later that we needed to deploy it to an OSU UIT supported environment, namely Azure. So I spent time working with the Azure pricing calculator to evaluate options, and I built the automation to auto deploy. The primary thing I learned from this experience is to press for the technical requirements early on with the project stakeholders.
My main contribution in the XP Hub was building out the admin front end, the interface administrators use to manage experience records. The core of it is a full CRUD workflow, so admins can create, view, edit, and delete experiences from a centralized management table. The interface was also built to align with OSU's accessibility guidelines. I added search and drop-down filters so records can be quickly narrowed down by campus, term, or status. The create and edit pages share a reusable form component so the interface stays consistent and there's less to maintain down the line. I also added a mock/live data toggle using mock service worker, basically so the front end could keep moving while the backend endpoints were still being built out. Under the hood, it's React and TypeScript, which kept everything type safe and made it easy to build reusable components. And by the end of the term, the whole admin view was fully wired up to the backend and running on live data in the deployed Azure system. Development started with a pretty bare-bones scaffold, hard-coded data, minimal styling, no forms, no types, just enough to see the shape of the page. From there, I got local CRUD working, so experiences could actually be created, edited, and deleted within the interface. That's also when I applied the OSU Style Guide and built the shared form component that both the create and edit pages use. That gave the admin system a solid foundation before any backend connections were involved. Once local functionality was running smoothly, I brought in a mock service worker to simulate a full CRUD API right in the browser. This way the frontend could keep moving while the backend was still being built out. When the backend endpoints were finally ready, swapping over was pretty straightforward. Create, update, and delete actions started firing real requests to the backend and database. Search and drop-down filters came in at this stage too, which wrapped up the core admin workflow. A couple things shifted from the original plan. The archive workflow was initially going to be its own separate page, but we simplified it down to a status filter. That way admins could just filter by open, closed, or archive right from the table, which honestly works better anyway. Unit testing and full workflow validation were also on the plan, but got deprioritized toward the end to keep scope realistic within the term. The priority became making sure the core system was functional and integrated. I ran into a few challenges during this project. The first challenge was being new to TypeScript. Managing types for all the data models and form fields had a learning curve. I worked through it using documentation, cheat sheets, and GenAI to troubleshoot, always verifying solutions myself. Second was setting up the MSW for the first time. I learned it through the docs and by referencing Joel's existing search app implementation, which helped a lot. Third was the API contract misalignment. I had put where I should have had patch and some field types that didn't match the backend schema. Regular check-ins with Neil and cross-referencing the schema directly got that resolved. The biggest thing I took away was to really nail down the API contract early. Even small mismatches between front-end and back-end schemas snowball fast once you're deep into integration. I also learned that stakeholder requirements shift more than you'd expect during development, so building in flexibility matters just as much as hitting deadlines. And honestly, just keeping communication consistent with the back-end team saved a lot of headaches. Same goes for the task board. Having it up to date kept everyone on the same page throughout the term.
Hi, my name is Demetrius and I was the database developer on our project. As a quick overview, some of the contributions I made were database schema design, database and backend integration, database migrations, database CLI utility program, and also setting up in-memory data based on our ORM models. We use MySQL for relational database management system because of its widespread use, and it'd be a technology that other OSU students would be able to maintain for future terms. The same thing with Python because of its ease of use and maintainability, and because we can use Olympic migrations. And third is Docker for containerization local development. The first part of my process was gathering the data from the multiple sites from Dr. Jones for all the experiential opportunities that she lent us. I used this data to create a schema for the widest coverage of different opportunities. And once I had created this schema, I wrote a script in Python for seeding the JSON data of the samples that we use into database tables. And really the main task of this was to normalize data into a shape that the database can use and can be built upon. Next is I had integrated the backend app with the database that Neil had worked on to enable full backend functionality partway through our development this term. And then I added database migrations to upgrade the schema for team development. And last of my development process was I added a CLI database utility program that'll be pretty useful for quick backups and quick information gathering on the database. You can see some of the options on the right top left picture. I also added in-memory data that emulates real data for development and testing when live data is not available. One plan versus reality scenario that I had was I had initially planned on creating a search and filter functionality in the backend, but I realized that the filtering will be handled on the client side. And some challenges were gathering the data. It was quite a bit more involved than I had anticipated. I had to keep track of a bunch of fields and specific use cases and data that only certain types have had. And second was integrating the database with the backend. I really had to learn how to use Docker Compose and to be able to create the database, seed it, and then connect it with Neil's backend app. This was very useful. I learned a lot about database knowledge, and it was reinforced. It solidified my knowledge of Docker and containerization and how to implement database migrations with Alembic.
Hi, my name is Neil, and I was responsible for the backend API for a project. I implemented CRUD operations for experiences, including the search view, filter forms, and the admin view, and I built the backend using layers for endpoints, service logic, and persistence for better maintainability. We used Python due to its ease of use and the fast API framework for its performance, automatic documentation, type hints, and async support. I also aligned the backend with the database by creating an ORM data model and connected the backend to the MySQL database and an in-memory database for development. Um, so we use Python protocol classes to create the database interface and dependency injection to be able to switch between the in-memory and the real database quickly. And we use SQL Alchemy for the data model. I also integrated the backend with the front end with the help of Zach by creating contracts and the API spec. I set up the initial dev environment for the backend by creating containers for the backend and database. And I created a API test collection using Postman. So for the development process, it started by setting up the development environment in a dev container, and then writing the initial backend scaffolding and an initial hello world endpoint. And then I connected the backend to a MySQL image and ran both in containers using Docker. And then I created the ORM data model in the backend using SQL Alchemy, and then created DTOs, the DTOs required by the front end, and then implemented the endpoints for search and the admin view. And then I created an API test collection in Postman to test the endpoints. So for our original plan was to deploy staging and production environments on AWS, but learning all this technology was new to me. So AWS was also new to me, so it was a lot to learn. And with a short quarter term, we decided to put cloud deployment aside and have me focus on the backend product. One of the challenges I had was Docker and the dev environment setup. I had difficulty with dev containers with the CLRF and LF line endings. This would often break the run scripts, but I overcame them by using WSL and VS Code over Git Bash. And what I learned was to read docs better. I learned several technologies and dependency injection.
Next, I'll highlight the two main user-facing workflows in our deployed Azure application, starting with the student experience. A student can begin on the landing page to get a quick sense of what the ExpHub is. From there, they can navigate to the Experience Discovery page, where opportunities can be searched and filtered in one place instead of across multiple OSU websites. Here, I'll filter by campus to show Corvallis opportunities. From there, a student can open any experience to view detailed information and determine if it aligns with their interests. Highlight number 2 is the admin management workflow. In the admin interface, administrators can manage experience records through the management table, where experiences can be searched, filtered, and edited. Admins can create new postings directly from here. Here is the new student-facing experience page for this posting. Existing experiences can be edited at any time. And the experience can be removed when no longer needed. Looking ahead, future terms can continue building on this foundation by adding OSU login integration, AI chatbot support, analytics dashboards, workflow automation, additional accessibility, and user testing improvements. Our team's work provides a strong starting point for the continued development toward a fall 2026 pilot launch. Finally, we would like to thank Dr. Rachel Jones for her weekly guidance, enthusiasm, expertise, and vision for the XP Hub project. We would also like to thank Dr. Stephen Wu for his support and leadership in expanding experiential learning opportunities at OSU.